So that if f such that a to b and b to c are 1 1, then g such that a to c are also 1 1. Let x1 comma x2 belongs to a. Let g of x1 is equal to g of x2. That implies g of f of x1 is equal to g of f of x2 such that g is 1 1. F of x1 is equal to f of x2. Now x1 is equal to x2 since f is 1 1. So g is 1 1. Now another question. So that if f such that a to b and g such that b to c are onto, then g such that a to c is also onto. Solution. Given an arbitrary element z which belongs to C, there exists a pre-image y of z under G such that g of y is equal to z since g is onto. Further, for y belongs to B, there exists an element x in y under f with fx is equal to y since f is 1 1 onto f is onto. Now here given y का प्री इमेज x है, x का इमेज y है. So that now g of x is equal to g of f of x is equal to g of y which is equal to z. That showing g is onto since कोडोमेन is equal to range means z का प्री इमेज x होगा. Now inverse function. Let f such that x to y, then the f inverse is a function from y to x. If f such that x to y is bijective, then it is invertible. If invertible, then inverse exists. Definition. A bijective function f such that x to y has an inverse function. That means f inverse such that y to x given by f inverse is equal to y comma x such that x comma y order pair which is belongs to f. That means you can say f such that x to y and f inverse such that y to x. Thus, if f is bijective, that y is equal to f of x, the double implies x is equal to f inverse y. A function f is said to be invertible if f inverse exists. Definition 2. A function f such that x to y is said to be invertible if there exists a function g such that y to x such that g of x is equal to identity of x and fog of y is equal to identity of y. Then the function g is called invertible function or g is the inverse of f which is equal to f inverse. If f is 1 1 and onto, then also f must be invertible. Take an example. Let f such that natural number to natural number be a function defined by fx is equal to 4x plus 3, where image or range is given y is equal to y belongs to natural number such that y is equal to 4x plus 3 for some x belongs to natural number. So that f is invertible and find f inverse. Answer: let y is equal to f of x, which is equal to 4x plus 3. So 4x is equal to y minus 3, x is equal to y minus 3 by 4, which is belongs to natural number when y belongs to big Y, that is a range here. Let us take that gy is say define g such that big Y to natural number by g of y is equal to y minus 3 by 4. So, g of x is equal to g of f of x. In the place of f of x you put 4x plus 3, because here f x is equal to 4x plus 3. Now, in the place of x here 4x plus 3 is here. So, here in the place of y here, that is 4x plus 3 is here. So, in the place of y you put it 4x plus 3 minus 3 divided by 4, that means it comes x, which is identity of a natural number, means that is x comes from that is natural number to natural number, that is x part, this is y part, here y is the range. Now, fog of y is equal to f of g of y. So, f of g of y, in the place of g of y you put y minus 3 by 4. So, here x place में y minus 3 by 4 is given. So, in the place of x you put 4 into y minus 3 by 4 plus 3, which is equal to y minus 3 plus 3, that is equal to y, which is equal to identity of a y. Hence, f is invertible. Therefore, f inverse y, that is equal to g of y, which is equal to y minus 3 by 4. Now, you get the f inverse value. Now, similarly, another way you can solve it, 1 and on 2 method, that is, now you take that method. 1 let x1 and x2 belongs to natural number, let f of x1 is equal to f of x2, that implies 4x1 plus 3, which is equal to 4x2 plus 3. That implies 4x1 is equal to 4x2. So, x1 is equal to x2. So, f is 1 हो गया. Now, on to let y is equal to f of x is equal to 4x plus 3. So, y minus 3 is equal to 4x. So, x is equal to y minus 3 by 4. When y belongs to the range, that is big Y, which is x belongs to natural number. That is why f x is equal to, in the place of x you put y minus 3 by 4. So, 4 into y minus 3 by 4, that means in the place of x you have to put y minus 3 by 4, 4 put got, that is comes. So, y minus 3 plus 4 is equal to y. Now, go domain is equal to range, hence f is onto. Therefore, f is bijective. So, f is invertible. So, f inverse y is equal to y minus 3 by 4. Okay? Any method you can follow it. If f such that x to y is bijective, then f inverse of f is equal to identity of x, and f inverse of f inverse is equal to identity of y, where I dx and I dy are identity of x and y respectively. Another question, in addition g such that y to z is bijective, then g of inverse is equal to f inverse of g inverse. Now, you take first bit, proof. To prove f inverse of f is equal to identity of x, and f inverse of f of x is equal to identity of x for all x belongs to big X. Now, y is equal to f inverse of f of x, that is equal to f inverse of x, f inverse of x. So, that here f of x this is y, you put f of x, you got that is equal to y, that is belongs to F inverse. So you put y, you got f of x, that is belongs to f. That implies f of y is equal to f of x. So y is equal to x since f is 1 1, f 1 1 होगा तो y is equal to x होगा. Now y is equal to f inverse of f of x is equal to x, which is identity of x. X is belongs to big of x. So f inverse of f is equal to identity of x. Similarly, we can prove that f of f inverse is equal to identity of y. So how the both side we have to take, that is y, just like you think some hint, f of y is equal to identity of y. After that you can solve. So second bit, to show that GOF is invertible with GOF inverse is equal to f inverse of g inverse. It is enough to show that f inverse of g inverse of GOF is equal to identity of x, and GOF of f inverse of g inverse is equal to identity of z. Now f inverse of g inverse of GOF is equal to f inverse of g inverse of g, that is by associative law of f. So f inverse of g inverse of g, associative law you have to apply. So the GOF of g, it becomes identity of y, so that it becomes f inverse of f, that is the identity of x. Similarly, GOF of f inverse of g inverse is equal to GOF of f inverse of g inverse. Now take the associative law, g of f inverse, it comes to identity of x. So GOF of identity of x is the g. So g of f g inverse is equal to identity of z. Now GOF of inverse is equal to f inverse of g inverse. It is proof. Now take one question. Here given s is equal to 1, 2, 3, f such that s to s by f is equal to 1, 3, 3, 2, 2, 3. Here f is 1, 1 and 2. So if what is 1, 1, that means 1 3 के साथ, 3 2 के साथ, 2 1 के साथ ये लिंक दिया है, that is uniquely related. So it is also 1 1, and it's 1 2 also means here 1 2 3 the domain all are related, and 3 2 1 that is the range also S is given. So the codomain is equal to range, that's why it is onto f inverse is equal to 3 comma 1, just ulta, that is 2 comma 3, that is 1 comma 2. That f inverse just opposite relation is there. Other question also discussed and next slides.